We're continuing our learning with discrete random probability variables, and we're going to focus in this video on mean, which is also called expected value. So they're one and the same. So mean and expected value are the same. And then secondly, variance, and then lastly, standard deviation. And what I want to do is link back to what you should know already with statistics. Okay, so we can apply a lot of the same mathematics from statistics with a few little changes to random probability variables. You should know that statistics and probability are such a close thing, so it shouldn't be any great surprise. Perhaps in statistics you've looked at some of these calculations, and we would have a sample of discrete values like those there. So x means all the different scores. We got 2, 2, 5, 6, 7, 7, 13, 14. So we've got 8 scores. If we found the mean of all those, which is x bar, 7. We could go each score from the mean, so how much it varies from the mean. So first one is 2 minus 7 is negative 5. Last one there is 14 minus 7 is 7, etc. We can square that to get rid of the negatives. And what we did in earlier grades is that we looked at some calculations around that. Some of those calculations, as said before, could include things like the mean, which you should know very well. We need to identify how many data points there are. There are 8. Then there's this thing called the variance, which basically you might not have even looked at that but without knowing. But if you look at this here, that means the sum of the x minus x bar squared column. So this column here, x minus x bar all squared, the sum of that would be 140. And if we get that 140 and divide by the number of numbers, we would get what's called the variance. And more about that later. Perhaps you haven't seen that one before. Maybe you have, maybe you haven't. But if we take the square root of that variance, we get something that we should be familiar with, and that's the standard deviation, denoted by the Greek lowercase letter sigma. Both the variance and the standard deviation are measures of spread or dispersion. They tell us how far on average things are away from the mean, whereas the mean itself is a measure of the center. You should remember all those things from your stats. So applying some of these concepts to discrete probability distributions, we see some things that are the same and things that are mildly different. So we've got this thing called expected value. You might have seen that also in statistics, or probability, where we look at, for each element that exists, we can look at its expected value, which in statistics we might call E of x or just E, or sometimes EX like that, or sometimes like that. So what it is the number of trials times the probability of something occurring, and we can have a whole string of those. Okay, there can be a whole lot of different ones, and some of these things can be positive or negative. So we basically can have one or several of these together, and you might have seen that in statistics, or perhaps you might have seen that in your earlier probability. So that's called expected value. It's like a weighted average, or it's like a long run average or a long run mean, and basically it's very similar in meaning to the mean. So you can, if you say the mean, you can basically also say expected value when we're looking at probability. Using the preferred notation, expected value, or E of x, is sigma of x from, we sum from all possible values of x the product of the probability times each value of x. In a more compact form, which resembles a bit like what I was showing over there, we look at x we take the sum of all the values of x times probability of x. I'll explain that in an example if that's not clear right now. If you want to use mean instead of expected value, you might sometimes see this other symbol used, mu, which is a Greek symbol. Okay, so that also means the same as expected value. So just be aware that they have an equivalent meaning. Doing an interesting example here, we have a roulette wheel at a casino. Hopefully you know what a roulette wheel looks like. There are two different types. There's the French and the American type. This type has reds and blacks, okay, in slots, and 18 red and 18 black. There's one which helps the house to get its house edge, so they're always going to be making money in the long run. There's one green, and nobody wins on that. Basically, if you place $1 bet on red, which pays $1 back, that's even money. What's the expected value of my bet? So we can use our expected value formula for that, which I've written in. Now what we can do with this one, if we're clever, we can, it looks like there's three different elements that we'll be adding together, but we can combine this into win or lose. Okay, that would be the smartest way. So let's have a look at that. So we got 18 on 37 times 1. That's when I win, because there's 18 reds and I win $1. That's the even money part. Losing, there's actually more of a chance I lose. There's more outcomes that result in loss. So it's 19 because there's 18 plus 1, and they've all got the same probability, because if you look at the way, I won't try and draw it, it'll be pathetic, but the way a roulette wheel is with the slots, they're all identical geometrically, physically. So that would have a value of -1 because you lose that $1. And so if you crunch those numbers, you get an expected value of -0.027. So on average, I will lose 2.7 cents in the long run. Let's look at another example with expected value. A coin is biased. Alright, so it's in favor of heads. The probability of attaining a head on any toss is 0.6, not the usual 0.5. The coin is tossed 3 times and the results are noted if x is the number of heads obtained. So that's our variable of heads obtained. So that's what we're measuring. On 3 tosses, find e of x, expected value of x. So what we need is a table to look at the probability distribution, so we can get, remember we're looking at the number of heads, so we can get 0 heads, 1, 2, or 3 out of 3 heads. They're all possible. Now they need to be calculated, and that would be based on work we've done previously. To keep the video short, I'm not including this, but you could do a tree diagram or multiplication and addition principles to work out these probabilities I'm about to write in. So I've zoomed in there, and those are the probabilities. You may wish to pause the video to see if you can get the same calculations. Again, this is not the focus of this video. This pertains to stuff we've done earlier. So there's our formula for the expected value, or the mean. You can use mu or e of x. And so here we go. We apply the formula now, as shown there, and we just have to calculate that. Pause the video if you need a closer look. This would mean that an average of 1.8 heads would be expected. Now you can't have 1.8 heads, but this is just essentially a statistic. It's a measure. So probably closer to 2, but between 1 and 2 heads we would expect. Okay, more likely 2 than 1. The last part of the video looks at what we said we'd also talk about, the measures of the spread or dispersion. They might be called measures of variability when we apply probability. So we're not looking at the center anymore, we're talking about how things are spread out or how they might vary. Variability, for example, might be used in quality control. So we don't want to know just what the expected average is, but we want to know how much it might vary by, whether it's going to be consistent or inconsistent. Now we looked at the statistical formula for the variance earlier in the video. Here's the one we will use with regards to discrete probability, and the variance here, so the variance is abbreviated to VAR. The variance var of x is E outside of x minus mu, where mu is the average, all squared. Or there's another version of the formula, and this one's probably used a little bit more because it's easier for computations. Now be careful with it, that's the only thing. It's the expected value of x squared. So we have to find x squared first, minus the expected value all squared. I'm going to have to show you how we apply that because it's not immediately obvious. By the way, var x can also be denoted as sigma squared because it's the square of the standard deviation sigma, where sigma is that lowercase Greek letter. We're going to do standard deviation next in case you're wondering. So for this example, for this distribution, we have to find e of x squared and then e of x all squared, and then we can substitute that into the formula just above there to find the variance of x. First thing we're going to do is calculate e of x, so the expected value. So we know how to do that. So the expected value, as we did before, is calculated as such, which is just like the two previous examples on this video here. So it gives us a bit more practice in that, which is good, isn't it? And then we calculate that, and it's 2. Now we need to determine what is this e of x squared all about. Well, it's the same as e of x, but we substitute, instead of the variable x, we substitute the square of the variable into the same algorithm. So, and by the way, this first one was 0, so I don't think I'll write it down next time. So starting here, instead of x being 1, we're using x squared, which is 1 squared times 0.18 plus 2 squared times 0.4. Can you see the link between the line, this line and the line above? Plus 3 squared times 0.34, and then we crunch that. We get 4.84. Now the formula had this e of x all squared, so that one there on the end. So really that's just this result squared. So I might as well write that in too, and then we've got an easy substitution into the formula. So 2 squared is 4. So now we're ready for var x. Subbing it in, and remember it goes e of x squared minus e of x all squared. So that's 4.84 minus 4, which is 0.84. So the variance was 0.84. So on average we'd expect 2 with a variance of 0.84. That gives us some sense of the variability. So if the average is only 2 and the variance is 0.84, there's a bit of variation there. So as we said before, if you take the square root of the variance, you get the standard deviation. We saw that early in the video with statistics. So it's exactly the same with discrete random probability variables. So let's have a look at this example. Suppose that a discrete random variable x has the probability distribution as shown in the table. Find the standard deviation of x. So this is a nice compact one here. One way of doing this is as follows. Firstly, we calculate, just like last example, we calculate the expected value, and that would be, as we saw before, like using that formula, putting those in. Then we have negative 2 times a half plus 2 times a half, which is 0, and when you look at the figures there, that makes sense, doesn't it? So the average can be 0, the expected value can be 0. Now remember, we have two formulas here for variance. In the previous example, showed the second formula there in action. Let's show this first one to show that we can use this as well. So we have the e of x minus the average all squared. Let's use that one. So in this one, we can do a bit of simplifying first, because x minus 0 all squared, which, whoops, that should be an e there, which is just e of x, the expected value, squared. Okay, so we did this in the previous example. So there it is, and let's have another look back at the table so we remember what the values were. So we had first x value was -2, and it had a probability of 0.5. So we got -2 squared times 0.5, and the other one was 2, so we're squaring the 2 times 0.5. Notice the squared is on the outside of the first one there, times 0.5. So what we've got there is 4 times a half, which is 2, times 4 times a half, which is 2, so we have 4. And let's not get too carried away. That was the variance. So remember that that's another word for that is sigma squared. Alright, sorry, it's not a 6, it's a sigma. Sorry, it didn't quite come out as how I wanted it to come out. So it's sigma squared, so the standard deviation sigma is the square root of 4, which is 2. So the standard deviation is 2. So the measure of variability, standard deviation, is 2.